All right, so this is chapter 3, question 22, and it is starts to give us an example of looking at some Mendelian genetics, but looking at some human examples. So things will be a little bit different here. I mean, we could do it exactly the same way we did before, but I like to start looking at these things and start to diagram pedigrees. Even though we haven't talked a lot about pedigrees, we talked about them in class a little bit, and so just define a couple symbols. Sorry about that, just have to get my pen right. Increase my ink flow. So symbols. Female. Male. So that's female. Male. And then that's a female that's affected and a male that's affected. So affected means they have whatever disease or trait it is that we're looking at. And these are unaffected. Alright, so right now I have to make sure that you say affected. Affected, not infected. So infected means that you're infected with a bacterium or a virus. You have some kind of infectious disease. We're not doing that. So we are not infected. We are going to be affected. So that's alright. So that's about all we really need. There's not that much to pedigrees. And we'll get more and more practice with them. So, let's see. I'm just going to get rid of this stuff because I want to keep that stuff on the screen. So let's pretend we're on the chalkboard and just erase all that. All right, and we're just going to read this information and construct a pedigree based on that information. Alright, so, well, I guess if that's going to be yellow, let's make this green. Alright, so alkaptonuria is a metabolic disorder in which affected persons produce black urine. And so it's an enzyme. If you're defective with this enzyme, you get black urine. So alkaptonuria results from allele little a, so that's recessive to the normal big A. Sally has normal metabolism. So Sally here's Sally. Normal metabolism. She has a brother. But she's not married to her brother. Hold on a second. She has a brother, and he's affected, right? Alright. So, we know his genotype. And they're brothers. Brother and sister. We don't know her genotype. We know she has a big A, but we don't know if she has alkaptonuria or not. Sally's father has alkaptonuria, so here's her father. He's got it. Mom, so his father and brother has normal. Okay, well, if her father has it, then he has to give a little a to her, and mom gives a big A, so she has to be this. That makes her a carrier. Carrier can be written in a couple different ways. You can put a little dot in here. Sometimes that's a carrier, or sometimes they'll fill this in halfway and say they're heterozygous. Alright, so that we just kind of figured that out from looking at it. Now we can go look at the question. So I just sort of did all these just by sort of working through the problem and writing things down. I got A done already. So the mother's normal. So I guess we know this for the mother. But he's homozygous recessive, so that means that she has to have that. And so she's a carrier, he's affected. Mom and dad have the two kids, she's a carrier, and he's affected. So if Sally's parents have another child, and we couldn't, I think if we use a diamond, that means indeterminate sex. So we don't know what the sex is going to be. What's the probability that the child will have alkaptonuria? And if you had a big A, little a, that means we have a 1/2 probability of being little a, because it's just a test cross. You got 1/2 probability of big A, 1/2 probability of little a. If Sally marries a man, so here's Sally. Now she's going to get married. He's got it too, so she just happened to pick a guy somehow that had alkaptonuria. Seems like the odds are pretty low. I always joke that maybe they were at an alkaptonuria convention or something when they met. What's the probability that their first child will have alkaptonuria? Doesn't really matter that it's the first child. Pretty much all their children will have the same probability individually. Same thing. So if she's a carrier and he's affected, there's a 1/2 probability. You could write that as the probability of being affected equals 1/2. And so that's pretty much the whole problem for problem 22. We can get into some crazy probabilities here with some other pedigree problems, but the main issue here, or the main concept that we want to get across, is just sort of how can you use pedigrees to analyze things. And the only genetic concept that's coming in here is dominance and recessiveness, segregation of alleles, that if you're big A, little a, you got a 50-50 chance of giving either of the alleles to your offspring. Get used to some of these diagrams. So I think that will do it.